Welcome back, MSM3. Today we are talking about rotations, and we're going to talk about rotations for 2 days. Rotations are probably the hardest of all the transformations, so we are going to have lots of discussion about it. A rotation turns a figure about a fixed point, called the center of rotation, a certain amount in one direction, either clockwise or counterclockwise. The new figure is still called the image, and the original, the one that you started with. So picture this. Picture that this is the center of a clock, and that you have stuck this white original triangle onto the minute hand, and that as time goes by, the minute hand is rotating over here to the 3 to about 15 minutes past the hour. And so what you'll notice is the point that was once facing straight up is now facing to the right. But this distance from the center of rotation to the base of the triangle stayed the same as this distance from the center of rotation to the base of the triangle. So this one is a 90-degree clockwise rotation, the white figure going in the same direction that the clock hands turn to get over here to the image. And we are staying the same distance away from the center. So once I stick that onto the end of the minute hand, it stays at exactly the same distance away on the same point on the minute hand. So here we have the vertices of a trapezoid, and this is our original figure. Notice no tick marks for the prime symbol. We're going to rotate this trapezoid 180 degrees about the origin. So right now, the original figure is in quadrant 2. This is quadrant 1, 2, 3, and 4. And we want to predict where this is going to end up. We're going to go 180 degrees, which notice it doesn't say clockwise or counterclockwise because it doesn't matter. But if we're going to rotate it 180 degrees, it's got to pass through one quadrant, which would be 90 degrees, and into the next quadrant, which would be 180. So first I want to predict where it's going to end up. It's going to end up down here in quadrant 4. So to get from the origin to say Z, I would go left 1, up 2. Well, I'm in quadrant 2. I'm going to rotate my paper, and I'm going to go left 1, up 2, and that's going to be the location of Z prime. So now I'm going to turn this back and say to get from the origin to Y, I have to go left 1, up 4. I'm going to rotate my paper. I'm going to go left 1, up 4. That's the location for Y prime. In order to get to X, I have to go left 1, 2, 3, up 1, 2, 3, 4. I'm going to rotate my paper. I'm going to go left 1, 2, 3, up 1, 2, 3, 4. And the last point, W, I've got to go left 4, up 2. So I'm going to go rotate my paper. I'm going to go left 4, up 2. And now I have all of my coordinates for the new shape that's been rotated. So Z, which was closest to the origin, here is Z prime. Y, which stayed right here along the y-axis. See, ZY is up against the y-axis. So down here, Z prime, Y prime, up against the y-axis because I went 180 degrees. Y and X were along this short top. So now down here, Y prime and X prime along this short top. And the last one that was the furthest away, W, over here as W prime. So the coordinates of the new image is 4, -2. X prime is 3, -4. Y prime is 1, -4. And Z prime is 1, -2. And now I'm down here like we predicted in quadrant 4. What do you notice about the original coordinates compared to the image coordinates? So for example, W was at -4, 2. W prime is at +4, -2. So what happened to the coordinates? What we find is that both coordinates have become their opposite. And this is true when you are rotating 180 degrees. So if we look at, say, the coordinate for Y, Y was -1, 4. Y prime is now 1, -4. They've both become their opposite. So that holds true. A figure with coordinates 9, 3, 3, 5, and 1, 0 are rotated 180 degrees about the origin. What are the coordinates of the image? So the 9, 3, they're both going to become their opposites, -9, -3. The next coordinate, 3, 5, both will become their opposite, -3, -5. And 1, 0 will become their opposite, -1, and 0 stays 0. Now, 0, we are assuming 0, 0, the origin is our center of rotation for all of these. That, the center of the clock is right here at the origin, and we're turning things around the center of the clock. The vertices of a triangle, 1, 2, 4, 2, and 1, 5, rotate the triangle 90 degrees counterclockwise about the origin. So here is my original. I've got J, K, and L. So I'm going to go 90 degrees counterclockwise. So how do I do that? First, I have to realize that counterclockwise is going to be over here. It's 90 degrees, so it's only going to move by one quadrant because that's a quarter of a turn from quadrant 1 to quadrant 2. And so to get to J, right now I have to go right 1 up 2. Well, I'm going to rotate my paper, and I'm going to go right 1 up 2, and there's my J prime. K, I've got to go right 4 up 2. So I'm going to rotate my paper. I'm going to go right 4 up 2. So there's K prime. And then L was right 1 up 5. So I'm going to rotate my paper. I'm going to go right 1 up 5. And there is my new triangle. Now, it has rotated. Sorry, just trying to organize my papers here. So J, which was closest to the origin, is still closest as J prime. K, you'll notice how I went along this bottom axis, right, the x-axis to get over to K. Well, when I rotate the paper, if I go along this bottom axis, that makes this one K prime, and that makes the last one L prime. And you can tell that it's rotated. Now, this is a 90-degree counterclockwise, right? It went in the opposite direction that the clock hand turns. What are the coordinates of the image? So J, which was 1, 2, is now -2, 1. K, so that's J prime. K prime, well, K was 4, 2. It is now -2, 4. And then last, L prime is -5, 1. Is the image congruent? Did it stay the same size and shape? Even though we rotated it, it is still the same size. It is still the same shape. So we would say, yes, it stayed congruent. So that's one of the properties of a rotation, is that it has to stay congruent. You'll notice here, my two quadrilaterals stayed the same size and shape. Here, my two triangles stayed the same size and shape. So now we have a rectangle, and you'll notice that this rectangle kind of like straddles the y-axis. So some of it's on one side and some of it's on the other. So that's going to be a very interesting property. We've graphed the original. It says rotate the rectangle 90 degrees clockwise about the origin. So right now I'm on the y-axis. Clockwise 90 degrees means I'm going to rotate one turn, like one quadrant worth. So right now I'm straddling the y-axis. When this turns, I'm going to be straddling the x-axis. So in order to get to B, I've got to go right 1, down 3. So I'm going to rotate my paper, and I'm going to go right 1, down 3. I'm going to do that again. In order to get to C, I go right 1, down 5. So I'm going to rotate my paper. I'm going to go right 1, down 5. In order to get to A, left 1, 2, 3, down 1, 2, 3. So I'm going to rotate my paper. I'm going to go left 1, 2, 3, down 1, 2, 3. And last but not least, for D, left 3, down 5. So I'm going to go rotate my paper and go left 3, down 5. And here is my new rectangle. Now, in order for this to be a rotation, C and B, notice how they were one square on this side of the y-axis? So that makes this one B prime and this one C prime. They're the one square on this side of the x-axis. B was the closest one to the origin, so B prime is still the closest one to the origin. And then you've got AD. A was closest to the origin, so A prime, closest to the origin, D prime, furthest away. Now, if you were to take out a ruler or some sort of straight edge, and you would connect the origin to B, and you also connect the origin to B prime, what you will see is that they are the same distance, right? That little segment that I just drew in, they are the same distance, and they make a right angle. They make a 90-degree angle because we rotated the shape 90 degrees. So super cool concept here. If I do the same thing with, say, D, so if I go from the origin to D, and then I also go from the origin to D prime, I also get a 90-degree angle, and I get those two yellow segments that are the same length. So everything stayed the same distance away from the origin. When I rotated 90 degrees, each individual point rotated 90 degrees, and my shape stayed the same size, and they're both the same rectangle, so they stayed congruent. Last is kind of a tricky one. It says, describe a sequence of transformations in which the gray figure is the image of the white figure. So we're saying that the white figure is original, and we want to know how to get to the gray figure. So I'm going to start by doing the rotation first. I always do the rotation first because then I can do a very simple slide or shift after that. So this, if I rotate it 90 degrees, I only end up in quadrant 4. So I want to rotate it a full 180 degrees. So I'm going to rotate 180 degrees, which is going to put me left 1, down 5, left 1. It's a little tricky to see that one. And left 4. I don't know if I did that one right. We're going to check that one. Left 1, down 5, left 5, down 5, left 5, down 5. That's this one. Okay. I'm not sure I'm doing this one right. I may have to try this one again. Anyway, I know that rotating 180 degrees is going to end me up here. And left 4. Oh, there we go. Okay. So on this one, I actually had put it up the x-axis instead, up the y-axis instead of across the x-axis. So here I am. I've rotated my 180 degrees, and it didn't really leave me where I thought it would. Do you guys notice that they're not in the same like orientation? They're not facing the same way. I thought when I rotated it here, I was going to get something that I could just shift up, no problem. But I've rotated it too much. So rotating 180 degrees was not the right answer. If I only rotated it 90 degrees, and I go here and here, 90 degrees would have been the answer, because now notice it's in the same sort of angle, the same direction as the gray one. So I should have only rotated it 90 degrees. So instead of 180, rotate 90 degrees. And I went this way, which is counterclockwise. And so what happened was I was trying to get up here to quadrant 1, right? But by rotating it all the way to quadrant 1, my shape was not facing the right direction. If I only rotate it 90 degrees, you'll notice it's now facing in the same direction as the gray one. And now I can say, what's my shift? 1, 2, 3, 4, 5, 6, 7 up. Or this point, 1, 2, 3, 4, 5, 6, 7 up. So now I can say, translate 7 units up. And then the yellow, which started as the original white, I moved to the yellow when I rotated at 90 degrees counterclockwise, and then shift or translate 7 up would have landed me directly on top of that gray quadrilateral. So a lot of it is about saying like, oh, this is what I think is going to happen, and trying it out and seeing if it works. And clearly rotating 180 degrees did not land me with a shape that I could easily shift into place. And so I had to try a second method of rotating it 90 degrees.